Hello, welcome back once again. Today we have this interesting problem from Harvard University. And we're going to evaluate the 12th power of 2 all over 1 plus root 5 without any calculating device. Right? Now let's get started. We know this number 1 plus root 5 divided by 2 is a very special number which is known as the golden ratio, right? So we can say that the upside down is what we have right over here. So let's take note of the following. We know that m over n is equal to n over m to the power of negative 1. So this means the reciprocal of n over m is equal to m over n. So we need to manipulate this in order to get our golden ratio. So we can use the Fibonacci's method to solve this problem without wasting our time. So now, inside this bracket we have 2 divided by 1 plus root of 5. So this is going to be equal to 1 plus root of 5 divided by 2, which is the golden ratio, then raised to the power of negative 1 with this property here. So we have achieved it. So now we're going to write the expression 2 divided by 1 plus root of 5 to the power of 12 as in bracket 1 plus root of 5 divided by 2 raised to the power of negative 1, then raised to the power of 12. Now let us take note of this interesting property. When we have a to the power of b to the power of c, we can interchange the power and rewrite it as a to the power of c, then to the power of b. So we can rewrite this as the golden ratio 1 plus root 5 divided by 2 raised to the power of 12, then raised to the power of negative 1, right? So now we're going to call the golden ratio x. So we're going to let x equals 1 plus root 5 divided by 2. So our next target is to get the 12th power of x, right? Okay, now to solve this problem, let us recall this amazing formula from Fibonacci, right? So this formula is given by xt is equal to u of t minus 2, then plus u of t minus 1 multiplied by x, provided that t must be greater than or equal to 2. Amazing, right? Now, let us list few of the Fibonacci's number or sequence. So now, for us to get the Fibonacci sequence, let's start like this. We're going to start with 0 and 1. So these are the first two terms of the Fibonacci sequence, right? Okay, so for us to get the next term, we're going to add this term and the second term. So 0 plus 1 will give us 1, so the next term is 1. For us to get the fourth term, we are going to add the second term and the third term. 1 plus 1 is 2. For us to get the next one, add the third term and the fourth term. 1 plus 2 is 3. Then 2 plus 3 is 5. 5 plus 3 is 8. 5 plus 8 is 13. 8 plus 13 is 21. Then we keep going. Next one is 34. The next one is 55. The next one is 89. The next one is 144. And the next one we have 233, right? So we have just few of the Fibonacci sequence, right? Okay, but how are these things going to really help us to solve this problem? That is to evaluate the 12th power of this number. Okay, let's see the magic. Now remember that for this equation here to hold, t must be greater than or equal to 2. So which means that we're going to make use starting from here. Okay, So starting from here, then down to this place. Okay, now we need the 12th power of x. So we're going to let t equals 12. So if we let t equals 12, so we get x to the power of 12 is equal to, then we derive the following formula. U of t minus 2 will be u of 12 minus 2, which is u of 10, which is the 10th term, plus, let's put x first, x multiplied by u of 12 minus 1, which is 11. So this will be equal to, now u of 10, let us check the 10th sequence, starting from where I told you guys earlier, since t is greater than or equal to 2. So count it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 89 is the 10th term. Then plus x multiplied by, we know the 11th term is after the 89, which is 144. So we have 144 times x. And remember that x here is the golden ratio. So we get x to the power of 12. Remember, this x to the power of 12 is equal to the 12th power of the golden ratio, 1 plus root 5 divided by 2. So this is equal to 89 plus, so 144 multiplied by x will be 144 multiplied by the golden ratio, 1 plus root 5 divided by 2, right? So this will be equal to 89. We know that 2 here is 1 and 2 here is 72. So 72 times 1 here will give us 72, then plus 72 root of 5, right? Okay, so from here we get the 12th power of the golden ratio, 1 plus root 5 divided by 2 to the power of 12 will be equal to 89 plus 72 will give us 161, then plus we have 72 root of 5. Amazing. Wow. Okay, you can see with this Fibonacci sequence and formulas, we're able to quickly get the 12th power of the golden ratio. But remember that we need to evaluate the reciprocal of this 12th power, right? Okay. So now, let us take the reciprocal of both sides. So when you raise both sides to the negative 1 power, so raise both sides to the negative 1 power. Remember, that is what we are looking for, right? So let's go back and check. Yes, of course. So you can see it right over here. Okay, so now from here, what do we do next? So, we can actually write this as exactly the expression we're asked to evaluate, which is what? 2 all over 1 plus root of 5, then to the power of 12. So this will be equal to, remember, raised to the power of negative 1 means 1 all over, right? Yes. 1 all over 161 plus 72 root 5. So all we need to do is just to rationalize by conjugation, right? So the conjugate form of this is 161 minus 72 root 5. So we're going to multiply the numerator and the denominator by the conjugate form. So we get upstairs here 1 times 161 minus 72 root of 5, then divided by, we already have 161 plus 72 root of 5, then we're multiplying by 161 minus 72 root of 5. So downstairs here we just have the difference of two squares, right? So now we get here 2 divided by 1 plus root 5 to the power of 12. So this will be equal to, upstairs there we get 161 minus 72 root of 5, then divided by difference of two squares, so that will be 161 squared minus 72 root of 5 squared. Okay, but fortunately 161 squared is equal to 25921, right? And the 72 root of 5 squared is equal to 25920. So their difference is just 1. So here we have our solution. That 2 divided by 1 plus root 5 to the power of 12 is just equal to, remember the difference here is just 1. So we just have the numerator as our answer, 161 minus 72 root of 5. Amazing. Thank you for watching. Please kindly subscribe to my channel. Also like, comment and share. Bye bye.